Okay, so we'll be starting now.
Okay, so good evening to one and all present with us this evening. Today, ISA-VIT is going to present you an interesting speaker session as a part of ISA 2021. Today's session will be led by Mr. Sharath Thomas, a certified Google Cloud engineer and a proud VITian. Mr. Sharath is an electronic and communication engineer having a vast knowledge in IoT and machine learning, and we are truly honored to have him here. He will give us an introduction to dev tools. We will be discussing the many dev tools that exist which can be used for varieties of reasons such as configuration management, test and build systems, application of development, version control, and monitoring. We will talk about the version, various applications and utilities of this above mentioned tools and how to use them in a real life scenario. So without further delay, let's get started.
Hello guys. So we'll start with the session, I guess. So my name is Sharath, and this is an introduction session to DevOps. So what is DevOps? Okay, so when you think about DevOps, it's a short form, I guess, for development and operations. So you have in a company, you have different types of teams, right? You'll be having the development team, you'll be having the quality assurance team, you'll be having the operations team. So what you do is you take all these jobs, you try to bring them all together so that they can work together, and there will be less communication gaps between them. So the production happens faster, like better updates, faster updates, all these happens. So this is the ultimate aim of DevOps. So when you think about software engineering, what do you think? The major part happens in the development process, right? So actually, the major part happens in the whole part after the development. What comes after development? Like you need to, if it's a website, you need to host a website. You have to make sure it runs smoothly, it scales properly, so that you don't get the unable to connect error or something like that, or the servers don't go out, or something doesn't happen. Then the regular updates has to happen. So all this stuff constitutes the major part of when it comes to the company, when you're having a company and you're rolling out a software. So then what are the stuff that a DevOps engineer is responsible for? First of all, it's deployment. You need to deploy the code. Whatever code you made, you have to launch it to the real world so that people can use it. I mean, that's the major part of a software developer's job, right? To deploy the code. Like you made something, you have to give to the people for them to use. Then you need maintenance. You need to maintain the servers. You need to maintain the code. You need to make sure that it's updated. If something happens, it's fixed. So that's the second one. Then you need to monitor your code. You have to your servers. Then everything has to be monitored to make sure that everything is working fine. It's healthy. So this has to be done. Then obviously security. You need to make sure that everything is secure. Like some hackers or crackers, I don't know, who are are not trying to get into your system, steal your data, all this stuff. Then there's automation. So automation is so basically automation just asks you how much of this job can be done automatically so that many people can be displaced from this job. Okay, so it might sound fearful, but actually the thing is instead of wasting so much human resource on, hosting a website, then making sure everything is running properly, this whole stuff can be automated so that you don't have to arrange people just for that. They could focus the job more on the development of the code rather than the deployment, the security, all this stuff. So this is what DevOps is. Okay, so a picture is worth 1,000 words. Okay, so I'll just go with an example. It becomes easier for you to understand. This is a typical scenario. Okay, so Star Garage's IT services. They use a Python-based backend infrastructure. Cool. So, suppose they have a website. They're a company who rolls out websites, and they're using Python for the backend purpose. And meet Shyam. Shyam made his part on the server using Python 3.6, and then Flask is a framework which you use for backend service, and he used 1.0.4. And then Shyam makes his code, he packages everything, and he sends his code to Babuya. And then there's Raju. Okay, so Raju's cooler, so he uses the more recent version. So he used Python 3.7, and he used Flask 1.1.2. So, and then Raju sends his code to Babuya. And now meet Babuya. So he is very like strict about having his infrastructure running on Python 2.7. It isn't on Python 3. Now Babuya receives the code from Shyam and Raju. One is Python 3.6, the other one is Python 3.7, and both are having different frameworks, different versions of the libraries. Now, if he has to run the whole code together, how does he do that? If he is having a server, a typical, I mean, a virtual machine or something hosted on a cloud platform, I guess. So what will he do? He'll just, yeah. So what would Babuya do? So he cannot just go like put Python 3.6 and then Flask 1.0.4 over there, because then Shyam's like Raju's code might fail. So, and he wants 2.7 on his system. So what would Babuya do? Okay, so this is what he would be doing. Okay, and also this. So this is neatly arranged as this. And okay, cool. So, okay, I didn't go through all the logos. Don't worry, I'll share the PPT with the coordinators. If anyone is interested, you can get the PPT from them after the session. And then, do we need to study all these technologies? I mean, just look how many like different terms are the different company products are there. You don't have to. I mean, I don't know like most of them. I just copied these two pages from Google because I'm lazy. And so, what do you need to study? You just need to study whichever CI/CD pipeline your company is using. Or like if you are interested in a project or something, I mean, you won't most probably use it in a project per se, unless it's a like huge project and stuff. So in that case, you just pick whichever technology you feel like is necessary for your CI/CD pipeline. So now what's a CI/CD pipeline? It's continuous integration and continuous deployment. So I'll give an example over here. This, again, another image I took from Google. So this here is an example CI/CD pipeline. I'll just go with what happens. So here suppose you are a developer. Okay, Raju and Shyam. They are developers. They are writing codes over here. So they write their codes and they commit their code using Git, and they put it in a Git repository. It's like most of the people use GitHub for their projects and stuff. You have Google Cloud source repositories for like Google Cloud. You have GitLab. I mean, people use GitLab for projects too. Then there's a lot of other Git repositories too. You use whichever you want, like as per your company's need or your project's need. So whatever code you have made, you made a new change to the code. You made some updates. You push that code to GitHub Git repository. Now there's this person called Jenkins. Okay, so what's the job of Jenkins? What Jenkins do is he will see whether any changes has been made to your GitHub repository if you're using GitHub. So he will just see every now and then whether any changes are made to the code which you have put in Git repository. Suppose you made a new commit, then you make a new commit with the new update, you pushed it. Now Jenkins has seen that, yeah, there is a new commit available. So what Jenkins do, he will pull this code, whatever update you have done, then he will run some test. I mean, like he will check whether everything is working properly, whether there are any errors. So if there is no errors, then what Jenkins will do, he will package the whole stuff and he will send it for deployment. So this is the whole continuous integration part. So whenever a new code is made, your new code will be automatically taken, the update, whatever update you have done, it will be automatically taken, it will be automatically packaged, and then it will be sent for deployment. So that's the job of Jenkins over here. So what this dude does, he will see whether any changes is there. If any changes are there, then a build trigger is a build is triggered. So a build means a new building of your software. So like suppose you have a Python package, I guess I like a Python code, then it will just run the Python code if it's a Python. Then if it's a Android app which you're making, then it could possibly package the whole app and make the final APK file. So that's what Jenkins does. Whenever you make a change, you make the change to the code. Now Jenkins will automatically make the APK. That becomes easier for you to understand, right? Yeah. So you make some update, Jenkins will make it into a new APK, and then it will send it to some place where it can be deployed. So suppose you made a new website. So your website will be stored in this using this technology called Docker. I'll talk about containerization. So once this is done, what it will do, it will push this new image. I'll talk about this thing. It will push it to a registry. A registry, it's like GitHub, but for containers. I'll talk about it. And then what Spinnaker does, Spinnaker will take whatever new code has been, like new image has been pushed to Docker registry. It will automatically take this one. It will assign this image to Kubernetes, and then Kubernetes will deploy the new code, the new updated version to your cloud, so your cloud platform or wherever your server is. So basically, you make a new code. It gets built into a package. The package is stored elsewhere, and this package is taken from that source repository, and it is deployed automatically to the Kubernetes cluster. Like, think of Kubernetes as your server. Just think of it as server for now. It will automatically take the new, the updated package, and it will automatically serve, like push it to the server so that the user will get the new image, like the updated version of the website or whatever software you're building. So this is a CI/CD pipeline. So again, here we are using some technologies. You might be using this, you might be using another technology. Totally depends on you, your wish, or whatever the company which you're going to work for will be using. So this is an example CI/CD pipeline. So I'll just go into depth with different stuff. So first one is Git. So everyone might be knowing what Git is, right? I mean, if you're in an engineering college and you haven't heard of Git, I mean, I don't know what to say. Okay, so Git is basically a source, like version control management. I don't know the term for it. Basically, what it does is you have your code. It will, if you make some changes to your code, it will keep track of all the changes you have made to your code, so that if you make some mistakes, you can go back to your code. If you want to like keep separate tabs of different versions of your code, you can keep that. There's a lot of use with Git. I'm not going into detail with that. So Git is a software, and open source repositories, GitHub, GitLab, all these are repositories. So what are repositories? These are basically, I could give an analogy with Google Drive, I guess. Yeah, it's basically Google Drive for your code. So whatever you have done, whatever software you're working on, the code for that will be stored in these source repositories for you to refer later on, for another person to take it, for you to, I mean, in this case, you saw Jenkins taking the updated code from the source repository. So basically the use of GitHub or whichever platform you're using is to store your code. Now, yeah, if you don't know Git, learn Git. Please do learn Git. It's like one of the most important stuff which you have to. Yeah, I guess that's all I can say about Git. Yeah, and then this is how Git works. Do have a pen right here. So you made some changes. You added some code. Now you add the code to the staging area, and then once you add the code, now you have added some extra files. You made some changes. You add all this to the staging area. Once you stage the code, you commit the code. Once you commit the code, what it means is you are telling Git that this is a, you could say like something like a bookmark, I guess. It could be, right? Yeah. So it's like, so this is a checkpoint in my code. So these are the changes that I made so far, and there will be different checkpoints before, right? So if you make some mistakes or something, you can just go back to the previous commit. So like whatever changes you made in this checkpoint will be restored. It's if you're playing games, it's like the checkpoints. So once you commit the code, you can push it to a remote repository. So your remote repository could be GitHub, GitLab or something, or it could be even a remote repository sitting in another part of your system only. Like another directory could be your remote repository, it doesn't matter. So once you push your code, that code, the updated version will be available on the remote one too. And then you can pull the code. Once you pull the code, it comes back to your working tree. Working tree means the place where you are coding, the area like the place where your updated codes will be first. So you push the code, then you can pull the code. If I push the code, then another person can pull it from elsewhere. I could only pull it back for like later working if I made some changes or something. Yeah. Then Git checkout. Git checkout is when you have a lot of commits. You have made some checkpoints, right? So it's like going back to the previous or whichever checkpoints you want. So if you made some mistakes in the few like past 4 commits, you made some mistakes. So you can go back 4 commits to the commit which you know is working properly. So it's like the Control Z basically. And then Git merge or Git rebase is when you're working with like different branches. You can like have a main branch on which your code is, then you can make a new branch on which you make some other changes, which won't be reflected on your main branch, obviously. And then you can just like different people can be working on different branches. Then you can just merge the branch back to the main one. So you can add the code back to your main branch. There's a lot of stuff which is happening, so I'm not going into details with this. Now we'll go to the next technology, which is Jenkins. Jenkins is an open source continuous integration server. So I guess you already saw what Jenkins does, right? It checks whether there's any change. There's different ways of doing that. It doesn't have to be always checking for the change in source code. I'll talk about that. So Jenkins, what it does, it basically takes the code, runs whatever tests you have asked it to do. Then it will produce the output. So like packaging APK, for example, like you get all the code for your app, it will package it into an APK file, something like that for everything, whatever you are doing. So Jenkins monitors monitors execution of repeated jobs. Like you have, whenever changes are made to the code, you have to again and again and again run tests. You have to make sure that everything is working properly. So once this is done, so this is the major job of Jenkins. Then it's mainly used for continuous building and testing of software. I told you before, right? Yeah. Then immediate feedback on broken builds. So you can have like emails coming to your mail ID or your manager's mail ID whenever if some error is happening and you're packaging your APK. Suppose you're packaging your APK. If some error happened and the build is failing, you cannot build it. Then it will send an email or any kind of notification to whoever wants to get the notification. Then you don't have to manually copy the code from the developer's computer to the main server or the quality assurance team server. It automatically pulls the code from wherever you want. It gets it over here. It deploys it over there. And then automated deployment. Yeah. Then automated test execution and feedback. So you can run test. Like suppose you want to see whether how much load can your website, if the part of the website, how much load your website can undergo, or like what is the maximum stuff, or like whether it fails, whether it breaks. There are a lot of tests that quality assurance team does. All this can be done automatically. So this is the main UI of Jenkins. I mean, much wow. It was written in Java, so I don't want to hate on Java, but like, yeah, this is Java. This was made on Java, and cool. So you can see different stuff over here. So these are all different builds you are building. Suppose this is app 1, app 2, app 3, something like that. So these are different builds for different stuff. Then this shows whether the build is done. So if it's gray, it means the build is not done. If it's blue, it means the build is successful. If it's red, it means the build is unsuccessful. That's it. Then this is the weather. This shows the weather. So if it's sunny, it means it has not failed any times. If it's cloudy, it means it has failed sometimes. You can see there are like different. There will be it will be sunny. It could be partly cloudy. It could be raining. It could be thunderstorm. Depending on how many times the execution has failed, over it checks how many times you have run the code, how many times it failed. So it just shows the weather of your deployment, your build. Then this is the name. Then you have when was the last successful build happened. Then when the last failed build happened, how much time it took to run the test, how much time it took to run the build. And then if you can click over here to see what is happening. Okay. Yeah. Then this here shows the test result page the like what all have been running, how many tests, how many build have been running. You can see there are like 587 here. This again, I took these images from some random dude in like on Google Images. So this has run 587 number of times, and it has been successful. And this is basically how the build happens. So this is how you configure your build. So you'll be asking, how does Git Jenkins know when my code has been updated? How does it know where to look for? So this is where you just add, you can add your repositories URL, like github.com/your user ID / your repository name or whatever it is. Then if it's a private repository, which usually is when you're working with projects or companies and stuff, it will be private. I mean, like, you don't want it to be open source where people can like get your code. You have trade secrets or stuff. I don't know. So in that case, you can give Jenkins credentials. Like you can allow like Jenkins to access the code. So the credentials for that you can add over here. Then you can say local module directory. So it just says like if you go to the main the source repository, which directory you have to check whether any changes have been made, or like which directory you have to build. So suppose you have the whole company's code and you are making this build for just suppose it's a shopping like e-commerce website, you are making this build just for the shopping cart item, then there might be a like / shopping cart directory, right? A directory is a folder. So it might be having a directory like that. So it will build for just that directory. And then a repository depth. A repository depth infinity means like how deep inside the repository do you have to search for changes. Like if it's infinity, it means like anywhere any change has been made to the code, it will trigger one. And then this is like additional credentials. Like if you need to like give extra credentials to Jenkins, I'm not sure why this is used. So then checkout strategy, evaluate clean like clean checkout by first deleting unversioned ignore files, then SVN updates. So it's like you when you have made some unversioned or ignored files are there, then you don't have to consider it. Remove that, build with the rest of the stuff like that. Then yeah, this is how you trigger the build. Like how does Jenkins know when to? The previous part was where to. Now when to. So when to, it would be like you can either have it like trigger builds remotely. I mean, like you can run some scripts. You can run a Python script, JavaScript, anything, Java code, or like it could be anything. You can run it to like trigger Jenkins to like run the build whenever you want. Like you can make a website if you want, like, and then you can have a button. You click the button, Jenkins will run the build. It could be built after another project is built. So like there will be, you saw different builds over here, right? We have like this 1, 2, 3, 4. There are different ones. So it could be like if one previous build, if this build is depending on another build, then you can configure it to run after the previous build has been completed. So that can be there. Then build periodically, like you can give like every 1 day, 2 day, or 3 day, you have to run the build again and again. Then the fourth option is poll SCM. So this is basically where you poll the GitHub repository. So it tells this is a cron job basically. So H/15 shows that you have to run the code every 15 minutes. So it just tells your Jenkins to run the code every 15 minutes, like not the code, to share, like poll your repository to see whether any changes are there. So every 15 minutes, Jenkins will go and see if there is any changes happening in the code. If it sees that any changes is happening, it will like make a new change. So I guess that's it. And then this is telling what to build, and like, I mean like the final output part and the testing part. So here this person is using Visual Studio project, I guess. It's, I'm not sure with the .sln file and all. So whatever this person was working on, good for him. So the build version, then yeah, this is the command. This execute Windows batch command. So whenever the build is starting, Jenkins will run this command. So there's this bat file. It will, whatever is inside this bat file, it will run that part, and then execute this another. After this is executed, it will execute this command, the second one. Okay, so whatever it is, I'm not sure about all this stuff. Whatever this person is working on, right? Then, so this is the output part. In this output part, it just tells publish the test result. How do you want to publish the test result? So it will be publishing the test result as an XML file. So it will be containing all the data regarding the test, how the test went, what all have been done, what all outputs have been given out after the test has been run. So it's basically a report file. So this will be produced as an XML file. Then email notifications. You can this is from 2014. There are more options right now. So you can tell email notifications like person one. So suppose the manager or the project manager, the developer team, whoever you want, you can add their email ID over there and send email for every unstable build. Suppose your build is failing or something is wrong, then an email will be going with the test report saying that so and so is happening. Go check it out. Then send separate emails to individuals who broke the build. So if I made some changes, so I can if so and so person has made some mistakes, then the email will be going to them. You have made some problems over here. This test is failing. This suppose whatever is happening, it's failing. So there are more options right now, and that's about Jenkins. So I guess you got an idea. Okay, so basically what Jenkins does is it will either run the build every now and then, or it will check the source repository every now and then. Then it will, if any changes is happening, it will run the build, or you can run a script to run the build, or what was the other one? You can build after another project is completed. So these are the different types. Then you enter the repositories URL from where it checks the code. All the stuff is there. So now what happens is this whole stuff is done. And once it is done, it will, so you are building something, right? So whatever you are building, it will package it into whatever file you want. If it's the Java, it will produce the jar file. If you want the jar file, I'm not sure, I'm not much familiar with Java. So whatever file you want, whatever languages you want, it can run on that language. I mean, basically what you eventually do is you just run this command, right? You just run whatever command is over here on the code which you pulled from wherever you from the source repository. So it will run this command, and whatever output is coming, you can package it into whatever forms you want. So I was talking about Docker. So what does Jenkins will package it into an image of a container, and then it will send that image to another repository. It's a container repository, registry, you call it whatever you want. So now I'll talk about Docker. So Docker is a really amazing technology. I mean, I'll tell you why. So containers. I'll talk about containers first because obviously Docker works on containers, right? Docker containers virtualize the OS just like hypervisor virtualizes the hardware, blah blah blah. So it's like you might be familiar with virtual machines, right? You might be you will be having I don't know, if you're having a Windows PC on your system, you can have Ubuntu running inside a virtual box, virtual boxes by Oracle. So VMware, all these softwares are there. They basically run the operating system inside another operating system. So that's virtual machines. So what happens is you virtualize the entire operating system, all the files, everything. So container will virtualize the whole stuff in a sort of different way, which I'll show you. Now, what happens is inside containers, it will package only the necessary files that you need. I mean, your code, whatever the code which you want to run, the runtime for the code, the libraries needed, then the operating system stuff which you need for your code, all the stuff will be packaged inside the container. There won't be a single thing that isn't necessary for your code to run. So it removes all the, suppose you are using Ubuntu's image, it will remove all the video, audio drivers, all the extra stuff that doesn't need to be there when you're running your code. So it removes a lot of space. So I don't know, Ubuntu image is 5 GB or something, 4 GB, 5 GB. But the Ubuntu OS ISO file. But when it comes to the container, it's 300 to 400 MB. That's it. The remaining stuff is all removed from the 5 GB to 400 MB or something. It removes all the unnecessary stuff. Then you put your code, your runtime. Suppose you're using Python, you put Python, the necessary whatever libraries you need. Then whatever extra stuff you need for just running your code, you add it over there, and then you put your code, and then you package it as a container, and then you run your container. So yeah. So another feature of the container is that you don't need to configure anything on your, like if you have Docker on your system and you made a container on your system, the other person who is going to run this one for testing or like deploying, they don't have to worry about the libraries you're using. They don't have to worry about the version of the code you're using. Suppose you're using Python 3.6, doesn't matter. If they have Python 2.7 like Babaya, if he has 2.7, doesn't matter because you're having 3.6 inside the container. He doesn't need, like, even if he doesn't have Python in his system, your container will run. Why? Because whatever code was there, it's inside your container. Whatever Python files needed, the runtime, the programming, the language, the runtime files are there, the libraries are there, and the essential files for running the essential files of Ubuntu, whatever, if you're using Ubuntu image, will be there inside the container only. So even if you don't have Python on your server, you can run the container. So basically, yeah, you don't have to worry about the libraries you are using versus the library they are using. You don't have to worry about what you have, what they have. You just have to get the image from them. You just have to have Docker in your system. Then you can run the container. It spins up in like 5 to 10 seconds, or maybe even less. Like there are, like it depends on the content of the container. It can spin up from like 1 second, less than 1 second, to maybe like 10 minutes if you have a system like that. So yeah, that's about it. So you can see that like there will be the code will be there, the runtime, the system tools, the libraries, and then the OS will be there, right? So the OS kernel, the Linux OS kernel will be shared from the host. So I mean, if my laptop right now, my laptop was running on any of the Linux distro, and I have Docker installed on it, what Docker will do, it will take the OS kernel from my laptop's whatever OS is running, and the rest of the stuff, whatever is needed for the code, will be there in the container itself. So that's how Docker runs. Yeah. So Docker, LXC are some of the most popular implementations of container. So like LXC, I don't think anybody uses LXC as such. I mean, Docker is so huge when it comes to containerization and stuff. Nobody, like even I didn't know about LXC, and like, yeah. Then it can be run on any Linux server. It could be any virtual machine. You can run Docker on your VMware. If you have a VMware, you have a Linux distro inside your VMware, you can run Docker inside that. You can have it on physical host, like if your laptop, your PC is having any Linux distro, you can run it on that. You can have it on OpenStack. OpenStack is basically a cloud platform. Basically, all I'm saying is it could be virtual machines, it could be a host machine, it could be a cloud platform where you have like compute engine, like yeah, basically a working server on cloud. So it can run anywhere where Linux is there. And it can even run on Windows, but you just have to have some additional stuff, which is like WSL, Windows subsystem for Linux. So what it does is it will add all the necessary binaries and OS kernel, I guess. So whatever file is extra needed to run Windows, like Linux commands, will be added to Windows using WSL, and then you can run Docker on Windows too. Then while containers, you can easily move the code between machines without any modification. Yeah, I told you, right? You make your code, you send it to another person, they can run it without any additional configuration. All they have to do is they just have to install Docker, which is also very easy. And then ability of containers to work together. If there are like multiple containers, you can spin up thousands of containers at a go, and then these containers can communicate with each other. I'll talk about that too. Then this is an image, like this is how the technology went. So initially what happened in traditional servers, they used to have the hardware. On top of that, they will be having their operating system. Linux server will be there, and then they will independently run all the applications. There will be like, there are like 5 or 10 applications. All these will be running independently. Like not independently actually, they will be running independent. When it comes to the libraries and stuff, they will be independent, right? I mean, if you're having, suppose this is the one which Shyam gave, and this is the one which Raju gave, then what happens is these both will be clashing because this needs 3.6, this needs 3.7, and they'll be clashing. And then Babaya 2.7 installed. So this becomes an issue for traditional deployment. So what they came up with was virtualization. So when it comes to virtualization, they will add a hypervisor layer on top of your operating system, and then you will emulate like virtual machines. So what it does is it will emulate the hardware and the operating system, and these apps will be running as if this alone is a whole computer, whole server, and this one will be, the other one will be a separate one. So in this case, this doesn't have an issue, because here Shyam can have his 3.6, and here Raju can have his 3.7. Shyam's will be running here. Flask, whatever version is here, it will be running. There will be no issue. But the problem is again space which is occupied by stuff which is not at all like necessary. If you are having a virtual machine, like around like 20 GB or something is the optimum size which you give. So that's 20 GB of space allotted for each code, like not each code, for each like system or like each application. So that's a huge waste. So what we came up with is the third one. Here you're having the hardware, then you will be having this my mouse pointer. You'll be having the hardware, you'll be having the operating system, you'll be having the container runtime, which is usually Docker. So you'll be having Docker sitting on top of your operating system, and then you'll be having different containers for each app. So this container will be sharing the OS kernel from this operating system, all these containers. And then you will just pack the necessary libraries and binary files, and on top of that, your application will be sitting. So this whole stuff will be like, it depends on your application, but usually it's like somewhere in like 200 to 300 MB, your whole stuff will be done. Even less. If you're using Alpine, like Alpine Linux, the container is like 3 MB or something. Yeah, the whole operating system is just 3 MB. So the container, the image of the container, the whole stuff is just 3 MB. You can have it like that. And then you can have like multiple stuff will be there. So initially these were taking like 20 GB or much, and these are now taking just 200 MB or even less. So you can see how much space is saved, how much more stuff you can spin up. So suppose you're having like 1 TB hard disk, you can have like how many? Your operating system is taking up so much already, then this 20 GBs plus. So it is a lot of waste. But here you can have thousands of containers spinning up, and there won't be much issues with the communication or like ports and stuff. So if these applications wants to communicate with each other internally, it is kind of hard. Like, yeah, you can talk using localhost itself, but these different containers can communicate to each other seamlessly using. I will talk about how the communication happens next. This is again another image for how Docker and virtual machines are different. I'm not going it's just the same stuff which I explained before. So this is an example of a Docker application, Docker on a system. You're having the operating system's kernel or kernel files over here. Then this is a container which runs on Debian, which is a Linux distro. And then on top of that, you're having Java, and you're running a Tomcat server. Then you have another container which runs Ubuntu, and on top of that, you're running .NET application, and you're having an SQL server. And then for the sake of it, you're having an Alpine server, like Alpine OS, which is again another Linux distro. And on top of that, you'll be having the static binaries needed. So this is one example. Yeah, you can have Windows, like Windows 2, I guess, right? The Windows server is available in image form. I guess, I'm not sure. I guess it's there. So this is the whole how you make Docker stuff. So this is the registry. Registry, like I told you, it's like Github, but for container images. So what is an image and what is a container? An image is a template which becomes a container when you run it. So an image is like this, and this is the steps which you do to get the image, or like it's the image of the container. And once you run the image, it becomes a container. So you can just have like copies of the image, and then you can make them. It's like you have an image based on this image, you'll be building containers. So yeah, so these images will be stored in this registry. And these are different images. This is the image for Ubuntu, then Nginx, Redis, I guess. I don't know what this is, but yeah. So these images will be stored in the registry, or if you're using Docker Hub, then Docker Hub. It's like GitHub. And then once you Docker, if you type the code Docker pull so and so image, it will ask the Docker daemon which is sitting on your host operating system, like your host system, and then it will pull the image from the registry or from Docker Hub, and then it will put it in your this one, your local system. So the image will be available. If the image is already not there, if the image is already there, I don't think it will be pulling because the image is already there. So what happens when you build a file? So what happens is how you build containers is like layers of an onion. So the inside core will be the base image. Suppose Ubuntu is a base image. Python 2.7 on Ubuntu, Python 2.7 or like Python 3.6 on Debian, on Alpine, any Linux distro. It's again base image. So base image is the image on top of which you will be building your next layers. So suppose you are having a Python application, you can either pull Ubuntu, then you can install Python manually. Then on the next layer, you can add the libraries. On the next layer, you can add the code. Then you can run the whole stuff. Or you can just get the Python on Ubuntu image directly from the registry. Then you can add the necessary like the libraries and your code, and then done. So it totally depends on you. So what happens is when you build stuff, here you will be having the base image. On top of that, you will be putting your extra files like the binaries or the libraries and stuff. And then on top of that, you will put your code. Then you say which port you have to expose. So basically, like if it's a web application, you have to expose a port through which the data communication, the traffic will be happening, right? So like suppose expose 80 means the container will be exposing its port 80. So any other port, if you try to communicate, it will be closed. You won't be able to communicate with it. If you expose 80, then if you like hit the IP address of the container :80, then you can get the website which is running on it. If it's an Nginx server, you will get the Nginx welcome page if you're running it. Then you can give the command to run when you start the container. So suppose if it's Nginx, I guess it's like Nginx. I don't know. I'm not sure about the command. If it's Python, then you can just give Python so and so. Like if it's app.py, then Python 3 or Python app.py. So whatever command that you want to run once your container starts, you can give over here. So this forms your new image. So you can push this image to registry again. Just a second. Good. So you can push this image to registry. You can pull the image back to your system. All the stuff. You'll be having a local copy over here in your system too, in the images set. You can push it, like you can push this one to the registry. It's just like GitHub. You can have your code on your local machine, and you can have it on GitHub. And then when you ask Docker build, there will be a file called Docker file. So it will read the Docker file. So it will be having from Ubuntu 20. That means the base image will be Ubuntu 20, or from Python colon 2.7 hyphen Alpine. Then it will be taking the base images Python 2.7 on Alpine OS. And then next will be something like copy so and so, and like to given destination. That means you copy whatever files you need, the file for your app, you copy it from here and you paste it over there inside your container. So it will put the file inside that directory. And then there will be like stuff like APK update. You can run APK like apt-get update, or you can have like pip install, whatever commands you want, you can run. Those will be another layers. Then you can expose 80 if you want to expose port 80. Like different commands will be given like that. You can type in ports like from run. All this will be there. You can just Google Dockerfile example. You can see an example Dockerfile. I didn't add any over here. So that's about Docker build. So when you give Docker build, it will go through this instruction file called Dockerfile, and it will run those steps. Once those steps are done, you will get a final image, which will contain all your code, whatever you need. And then you can just give Docker run. Once you give Docker run, it will run your code. Like it will run your container from that image. So you can give how many like replicas you want. I mean, like how many containers you want. If you want like 5 containers of the same image, you can have 5, 10, depends on you. And then you can say which port to expose, all this stuff. So that's how it works. So to talk about our initial Bubaya issue, what they can do is, so Shyam and Raju, they can develop their code independently on their systems with no issue. Then they will package their code, and then once they package their code, they will make it as a container. Cool. So Babu, like Raju made his code and Shyam made his code. They made it into different container images, and then they store the container images. They'll store this. Suppose they're using Docker Hub. This will be Docker Hub. So they'll be storing all the codes along with the keys and values and stuff over here. And then what Babu Bhaiya does, he will pull this code from the online repository and he will deploy this code. He will manage everything. He will deploy. He will scale everything. All this stuff will be done by Babu Bhaiya. So they don't have to worry about which version each others are using. They don't have to worry about what the other person did. All this will be done automatically. So yeah. Now for Kubernetes. So what is Kubernetes exactly? Like there's Kubernetes, which has the major role right now. Kubernetes was developed by Google, and then they made it open source for everyone to like develop and stuff. And then there's Docker Swarm, which is by Docker. There's Apache Mesos, which is developed by I guess Chicago University, I guess. So what this does is, I was talking about containers, right? What if you have like thousands of containers? Like you have a container for each person's shopping cart. There is a different container, suppose. So there will be like, if you're like, suppose it's Amazon, you'll be having like millions of containers. You'll be having, if you're having a container for a set of products or for shopping cart, for the search bar, different containers are there. There will be millions of containers maybe. So in that case, how do you manage all these containers? Who will make sure that whenever a person clicks something, that container will be popping up without any problem? If 1,000 people click on the same stuff, how does it make sure that they don't get the traffic? Like if the traffic doesn't get capped, I mean, like too many users are there, the server doesn't throttle. All this, how does it manage? So this can be done by Docker Swarm, Apache Mesos, Kubernetes. There are many other platforms too, but Kubernetes rules the market. For like small clusters and stuff, it's cluster of containers. So for small clusters, you can use Docker Swarm. For like big users, obviously you have to go with Kubernetes because that has become the industry standard now. Yeah. Then yeah, what is Kubernetes? What does this like? What happens actually? So suppose this job recruitment website. So initially, what happened? There are like job applications tabs are there, job vacancies are there, then the recruiter tabs are there. All these are data. There are like files. There are website like web pages for each. So now you split everything into microservices. So instead of having a big application, you split everything into small services. Like recruitments will be happening in one place. Then job applications will be handled by another one. Job vacancies will be handled by another one. So these three will be like transformed into 3 Docker containers. So there will be 3 Docker containers: one for recruiters, one for job applicants, one for job vacancies, and then you will convert it into Docker containers. And then what you do? You ask Kubernetes to manage these containers. So Kubernetes will, like suppose like 100,000 people came to your website, to the recruiters tab. Now, what Kubernetes will do, it will spin up like thousands or like maybe 1,000 or like 1,000 or something of containers of this one automatically. You don't have to configure like say like 1,000 servers should be deployed or something like that. Kubernetes, along with if you're deploying it on cloud, it will auto scale. I mean, like it will start new virtual machines inside which the Docker containers will be running. It will automatically spin up 1,000 containers for you. So when the traffic is high, once the traffic is low, it will automatically shut down the containers. So like it won't stay in 1,000 containers. It will be one when like there's minimum traffic. It will be 1,000, 10,000. It depends on you. You can specify how many containers you want. Minimum 2, maximum 100. If you want only 100 containers at max. So that can be done. Then you can say when to start the new container. You can say like when the traffic hits 70%, start a new container. Or the CPU usage is at 80%, start a new container. These all like specifications can be given to Docker file, like to Kubernetes in a YAML file. So that's how Kubernetes work. And this is the architecture of Kubernetes. I'll go to the next slide because this slide should have been put first, and then the other one. I'm too lazy to put this one. I'm sorry about that. Anyway, yeah, good. So this is the what Kubernetes has. Okay. So Kubernetes will be having different nodes. So a node, suppose like take nodes as different computers. Suppose you are having a local Kubernetes cluster. Think of each node as different laptops. Suppose you are having a cluster with 5 computers. Suppose think of each node as a different laptop. It becomes easier for you to understand. So this here is a laptop, and think of code as like another sub-module which has a few containers. Maybe like usually you put a single container. If you want, you can put like two or like multiple containers. It doesn't matter. So a group of containers which works together hand in hand, you can put them together in a pod, inside a pod. So inside a node, you will be having a pod. So inside the pod, you will be having the containers and volumes. So what are volumes? Okay, so I didn't tell about a drawback of container. So when you spin up a container, whatever data you created inside the container, when you delete the container, the data goes along with it. It's like starting a new laptop, turning off the laptop, throwing it away. It's just like that. You destroy the container once your job is done. So what if you have a database? Suppose you have a SQL database and you need to add some data which has to stay. When the next container is coming up, you need to have this data, right? So for that, you have something called like volumes. So a volume is mounted. It's something like a pen drive, like having a pen drive. You plug it in, you add whatever data you want, you add it to the pen drive. Once your container is lost, the pen drive is still there, right? It's like once you throw your laptop away, your pen drive is still with you. It's like that. You have a volume where you can store data permanently, and then it can be accessed by multiple containers at the same time. You're just mounting it. So this volume will be in cloud. You can have persistent volume disk in Google Compute Engine. In Amazon, you have it. I'm not sure with Amazon technology, I'm sorry. But yeah, that's about it. And then each pod will be having an IP address. These are the IP address of the pod. You can reach the pod using this IP address. And then inside this pod, these two containers, there are two containers. These two containers can communicate using localhost. And if this and this container has to communicate, they have to hit it through the IP address which was allotted to the pods. And then how does there will be a master server. This here is the master server, the master node. So how does the master node communicate with the slave nodes? Slave nodes are the ones which are running the pods. The pods are the one which has the containers. So it communicates using kubelet. So kubelet is the only source of contact for the master node to communicate with the slave nodes. And then the master will be, there are stuff like etcd. These are like storage volumes where you store details about how much containers you need for different containers, like different data regarding the containers, like the data of the worker nodes, the data of the different pods. All this will be stored as key value pair etcd. Then you have schedulers to make sure that, suppose you said, I need 5 containers running, minimum. So how does it know how 5 containers are running? Those schedulers will be checking whether 5 containers are there minimum. If it's not there, or if any of the container is having any health issues, I mean, if it's failing or something, it will shut it down. It will add new containers. The scheduler basically schedules containers running. So that's the job of the scheduler. Then controllers will be controlling all this stuff. Then API server. So API, you communicate to the Kubernetes cluster using REST API. And then again, this API server communicates with kubelet using APIs, this REST API. And each node will be having Docker runtime. So this is like a PC. Suppose this is your PC. It will be having Docker. Then it will be having a network proxy. So the user, suppose it's a website, the users, the people who are accessing your website, they will be accessing using this proxy. And you might be having a load balancer sitting over here. So what does a load balancer do? So the job of a load balancer is to make sure that the network is served evenly. Suppose 1,000 people are coming. You don't have to send all the 1,000 people to the same server, right? It can be distributed according to your geographic location, according to what the current traffic of the server is. So load balancer will distribute the network, and all the different servers together will be having a single IP. So this will be your external IP, like www.google.com. So when you hit google.com, it goes to a load balancer. The load balancer will distribute your traffic to the nearest server, or whichever server is having the least traffic, or whatever algorithm it follows. So you'll be having a load balancer. This load balancer will be sending your traffic to network proxy. So network proxy will be the communication point of the end users. Good. That's about Kubernetes. There's a lot of stuff which I have to tell about Kubernetes, but I don't have the time for that. Then there's Spinnaker. Spinnaker is one of the many technologies there is for continuous deployment. Okay, so Spinnaker was developed by Netflix and they made it open source. So this is a pipeline example using Google Cloud Platform. You are a developer. You made some new updates. You added the updates to Google Cloud Source Repository, Github. Then cloud build. Cloud build is something like Jenkins. It will see that there's some code change has been happened. So cloud build will be triggered. Cloud build will build a Docker container. So this container will be sent to Spinnaker. Now what Spinnaker does is, before that it will be storing this container inside container registry. That's like Docker Hub. That's where you store the image of your container. So from this one, Spinnaker will see that a new version of the image is coming. So Spinnaker will take that image. It will send it to Kubernetes Engine or cloud storage, depending on whatever the necessary is. Like the image will be stored in cloud storage, or it could be container registry over here. So, or if you need some extra storage for running your code, it will take it from the cloud storage. Cloud storage is basically just storage, raw storage like Google Drive. And then Kubernetes Engine is a service by Google Cloud Platform, which basically gives you Kubernetes. That's it. Yeah, Kubernetes. No biggie. And then it will run send this image automatically to Kubernetes to run. And now what Spinnaker does is it will deploy using Canary. So I'll talk about what Canary is. So the app will be, the updated version will be deployed in your Kubernetes cluster. The set of servers that's running your code, the new code will be put and the old code will be taken down. And then there is cloud load balancing. Cloud load balancing is a service by Google Cloud Platform, which again I told you what cloud load balancing is, right? So it will the users. Suppose you are the user, you are having the if it's the website, you will be hitting cloud load balancing using the IP address which the load balancer provided, and then load balancer will automatically distribute the traffic to the old or the new version, or how many other containers are there, or whatever nodes are there. It will distribute it immediately. So this is how the whole stuff happens. So what is your part in this one? As a developer, all you have to do is make changes to your code, push it to cloud source repositories. This remaining whole stuff will be done automatically. So how many people's job has been displaced by this code? I mean, there used to be someone who needed to take the code from this person. Suppose initially they had to take this code, then they had to deploy it in server. They had to make sure that all the versions are working properly. So suppose there is a communication problem, like communication gap between the deployment team, the quality assurance team, and the developer team. So if there is some communication gap, they won't be knowing which version of libraries each person is using. There might be a communication gap between different developers. One person is using Flask, one version, the other is using another version of Flask, and then the quality assurance team is having another version. So they cannot just change the versions, right? If I change my versions, my code might not work. And I cannot expect the other person to change their version for my code, right? So these were all different problems. So the updation time for codes used to be so much. Like it took weeks for an update. Once you make the developer makes a change, it took weeks for the update to be finally rolled out to the user. Now it gets rolled out in matter of seconds. I guess every 12 seconds or 13 seconds. Like big companies are having update to their website every 12 or 13 seconds. So that's how fast new updates are being happened. And this whole stuff became automatic. So this is again another flow diagram for the same stuff. You make changes, you tag it, and you push it to the repository. Now Cloud Build will see that a new tag is happening, like a new commit is made. It will make a Docker image. It will run the test, whatever test you have to make sure that it's running properly, right? So like the traffic is out properly, whether 404 is coming. All this will be tested, and then it will make the image, and then it will push the Docker image, and then Spinnaker will detect that there's a new image is happening. It will deploy it to Canary. I'll talk about Canary in the next slide, and then again it will run some tests to make sure that the container is running properly. There is no error. Nothing is wrong with your container, the image, and everything. So once everything is done, everything is perfect, you can have a manual approval system. So manual approval system is like mailing someone, do you want to proceed with the new update? This and this has been the changes made. The log file for the changes will be run, the build test file will be sent, and then the person can approve it. Suppose I am the person who is in charge of operations, the operations lead or something. I will press approve, and the new code will be deployed to the end users. So this is how the flow works in a company. again another image for the same stuff. Here we are using Jenkins, and then Nexus is a Docker registry. Nexus, Docker Hub, Google container registry. It doesn't matter, any technology. Then here Prometheus is there to monitor. In Google, you have cloud monitoring, logging. There's a lot of software is there for checking whether if everything is working properly. So it will, there are health checks. So it will check whether the container or the node or the server, whichever is running properly, whether everything is happening properly. So these like monitoring can be done to see whether, like, if the CPU utilization is going above 80%, you can get an email notification saying that CPU notification, like the CPU usage is going above 80%. Please do something about it. Or you can have it even like when it goes above 80%, you can deploy like add a new container. Suppose it goes above 80, you add a new container. The traffic is split between these two, so that it doesn't go even higher. So all these are different stuff that can be done. Then yeah, this is about Canary. I told you about. So these are different techniques of rolling out an update. So initially, what there was this blue green or a red black, whatever you call it. So you will be having the load balancer and yeah. So initially, this is the blue. Blue is the old code. Green is the new code. Cool. So you are having the old code on this many number of servers or containers, whatever you call it. So these many servers or containers were running the old code. Now you deploy the new codes on new servers. Now there are equal number of servers in the old one and the new one. So once it has automatically successfully deployed this many new ones, it will switch the traffic from this one to this one. Now whoever is coming next will get the new one. Whoever was on these servers before will be getting the old ones. And after every user has been like, if all the users of this one is gone, this will be shut down. This will be shut down. This will be shut down. So like that, once every user is over, this whole containers or servers or whatever it is will be taken down. This was the initial method. So instead of that, the rolling updates came. So in rolling updates, what happens is, initially you'll be having this many containers running in the old one. Then what you do, you start a new container with the new code. Then you redirect the traffic of one of these containers to the new one. Once all the traffic is gone, you delete this one. Then you add a second one. Then you send the traffic of this one to the second one. So like that, you add a new one and delete a new one, add a new one, delete a new one. So finally, all the old ones will be gone and the new ones will be coming. So that was the second method. Then there was Canary method. So in Canary, it's almost similar to rolling update. What happens is you are having the old code will be here. You can see the old code, right? Yeah, these are the old codes, and this will be the new one. These are the servers for which the new ones are assigned, and then it will start a new container. It will start a new container with the new code. Then it will run all the tests. That's the difference between the previous rolling one and the Canary one. It will run tests to see whether everything is working properly, whether the user is getting the traffic properly, whether they are experiencing any like problems, like if it's taking too much time to load. It will check all this stuff from the end user itself. So some of the users will be like guinea pigs, like that came out wrong. So yeah, some users will be the test subjects. So you will be testing the new code on them from the new one container, and it will see everything is working fine. Then yes, cool. And then that will be fixed. Done. If something is not working properly, they will automatically be shifted back to the old code, and then new one will be removed, and then you will be getting a test report saying that this and this is the issue. You'll be logging everything, right? You'll get the test report saying that sorry, this and this is happening with your code. Go do some changes. And then if everything is fine, then again, next set of people will be added here. Then again and again, the test will be running and again until the first one is done and the updated code is done. So that's about deployment. Cool. So I guess my session is over. Yeah.
Sir, thank you so much. You gave us a lot of knowledge. It was a very detailed session. We have some questions, one or two questions that came up, and I would like to ask you one or two questions that came up. Okay.
Sure.
So yeah, what is the most interesting thing that you've made using DevOps so far?
So I made a website. So the website is not the interesting part. So I made a website which basically what it does is it takes some data from Firebase. You know Firebase, right? It's a database. So it takes this one and it plots a graph. So this website was made using Python and some libraries. So I had to make it into container because it becomes much more easier for me to deploy, right? I was supposed to like send too much traffic to see how much, like how it works fine. So what I did was I made a container. It was not working. I worked on it for like a few months, I guess. It took me like a few months to make sure that everything's working. It needed a certain version of Python. Then it needed, it needed Node.js on top of Python. Like it used both Java. Like it was using TypeScript. Yeah, it was using TypeScript and Python. So I had to add all this stuff. It took me like a few months to finally configure it. Then I sent it to Google Cloud on Kubernetes Engine, and it was working. Then another one would be there was a person, like it's like a social media website, again a website which I made, and then I had to deploy it on. I made the Docker file. I deployed it on Kubernetes Engine. So what I didn't do was I didn't check the cost. So it was billing me around 2,000 something per month for a website which I was doing for fun. I just made it for fun. So just to make sure that I know how to do it. And then it was billing me around 2,000 per month. It was on free credits. I had free credits, so obviously I didn't pay. And then finally, after like 8 months or something, my credits got over. I was checking the free credits and I was like, okay, fine, it's over. Now I have a bill of 500 extra. So yeah, I guess that's it.
One more question we have. How is DevOps different from agile software development?
Okay, so I have to go through what agile is. I have heard the term a lot. Agile, I guess it's like it's a method, right? Like I mean, for different types of people, like different types, like different teams to work together successfully, like in collaboration. So I guess I'm not sure about what agile is, but if that's correct, then DevOps is a method of agile development, I guess.
Okay, sir, we don't have any further questions. I think you explained it very nicely and all the questions were answered. So thank you so much for taking this session. Samrit, can you please conclude?
Yeah. We are honored that Mr. Sharath Thomas accepted our request to give this speaker session today. It was a very enlightening session, and we surely learned a lot of interesting things today. We appreciate you taking your time out and joining us today to make iHack a grand success.
Thank you so much, sir. Thank
Thank
you.
you, sir.